All right. Timer started, but I do want to do. I was thinking, um, right? Like I should be able. Let's see. Okay, let's do two things. Let's get ChatGPT open, and then let's get a new. Uh, okay, we have a new window, and then let's create a new input. macOS screen capture, okay. Um, not display application, and then chat GPT helper is correct. So let me see. Chat GPT. Where did it go? Um, Maybe I just need to share chat. Uh, Bro, what is going on? Let me see here. Okay, let's get rid of this. Here we go. This, it says ChatGPT helper, but I want ChatGPT. Maybe it's a window capture? Oh, why is it? Okay. Oh, there we go. And I really need something better here for this. I know they have something called like a stream deck, and it's basically just programmable buttons. Uh, there's different scenes. Oh man. Okay, I'll figure that out next time. For now, what I wanted to do here is say, okay, if I can you take a PDF as context for a chat? So the thing I was thinking is I have a PDF of this entire textbook, right? And I can read and use its contents as context for our chats, whether you want summaries, flashcards, code extractions, question answering, or anything else based on the PDF. So, I mean, theoretically then, right, let's try it. Let's go Finder, Desktop, and then it was DDIA. All right, here is a PDF of a textbook. Um, let's rename. Okay, so I all right, the first time I tried to do the flashcards, right? Uh, and what happened? Maybe I can do a project. Oh, interesting. DDIA. add instructions, tailor the way. No. Um, let's upload the PDF here. Finder, DDIA. All right, for this project. Okay, so that was a chat, but now I have a project. Okay. Uh, huh. Oh, here we go. Look, it kept that. That's nice. Yeah, this is way better. Mm. Okay. Oops. Uh, Interesting. Huh. Okay. All right, let's keep going. Um, hmm. Um, Okay, so where am I at, right? I'm in chapter 2 right now. Like, I wonder if it would be like nice to oh. I'm not reading both of these, so I don't care. Data models. Relational model, document model, graph model, relational model, schemas, tables, and foreign keys. Guarantees normalization to reduce redundancy. Popular due to SQL. Decades of ecosystem development. The document model is more flexible, allows nested structures and schemaless documents. Popular in NoSQL systems like MongoDB. Good for applications where one document equals one object or entity. Yeah. The graph model represents relationships as first-class citizens using nodes and edges, useful for complex relationships. Query languages. Declarative languages like SQL specify what you want or how to get it. Imperative code and application logic is more error-prone and harder to optimize. And then graph databases uses stuff like Cypher, Gremlin. Data locality and duplication. Document databases may duplicate data for performance. Relational normalization avoids duplication but can require joins. So normalization versus denormalization, flexibility versus consistency, and performance versus maintainability. Here, let's do um, this is super interesting. Okay, let's copy all these down. Now let's go to Obsidian. Down here and just paste them in. And then let's go look. Oh, no. What? New cards, 4. 1, 2, 3, 4. There's more than that. I wonder. Has to do that. 12. Yeah. Oh, I see. Okay, so know how. Let me test it, I guess. Maybe this needs to be like this. But it's weird that it's all under P1, right? Oh, I see. I see why. It's not a folder. Okay. So how much sound do I have? Plenty. Oops. Okay, so now. No way, bro. What? Here we go. There it is. Yeah, but now it's like garbage, right? Fuck. Like I want to see this. So picky. And then just rename. Oh shit! Cancel. Rename this to notes. And then rename X notes and rename this. Alright, good enough, I guess. Hate that, but whatever. Now when I open this, better, right? Now if I do this and what is the document? What is the document model? When is the document model a better choice than the relational model? When you need flexible schema? Oh. Or embedded. Oh, okay. So look, this is missing stuff. Simple or embedded. So if I come in here, I bet, yeah. Flexible schema, nice. So you do that. So let's just fix all these real quick. And then that's fixed. We have this. Okay, almost there. Okay, so now if I come in here and I look at, now there's 15 cards. What is the graph data model best suited for? Social networks, recommendation engines, and network topologies. Say that was hard. What is the trade-off between normalization and denormalization? Duplication. So normalization will have uh, more consistency in the data because a lot of it's predefined. Denormalization will have better locality and more flexible schema, I guess. Normalization avoids duplication but may require joins and improves read performance, locality. I don't know if that counts, but increases redundancy and update complexity. That's an important one. Okay, so this worked. This worked, right? Um, Interesting. Hmm. Okay, so, and then in here, tailor the way. Um, uh, if I ask any questions, let's to quote the textbook. Okay, so something interesting too that I think would be cool. Huh. Hmm. I was just wondering, like, this book cites a lot of books, you know? I wonder, um, I wonder how crazy it would be to. Huh. Okay, so let's. Alright, I've spent a ton of time playing with this, but I think it was worth it. This is something interesting. You can basically handcraft your own tutor. Um, you know what I mean? Which is cool. I wonder too. Okay, I'm gonna do a quick Google search. What I'm searching for is like GitHub repo of uh, tutor context. Awesome GPT props. Let me see. Huh. So I'm looking at something right now that's like act as. So like act as a travel guide. I'm gonna use this after this, actually. So let's see. Let's do Croatia. Okay. So saving that for later. Actually, here, we'll use it. Okay, so like this prompt is, I want you to act as a travel guide. I will write you my location, and you will suggest a place to visit near my location. In some cases, I will also give you the types of places I will visit. You will also suggest me places of similar type that are close to my first location. My first suggestion request is, I am in Istanbul and I want to visit only museums. So this is super interesting. I want to see it do that. Did that not work? Oh. Okay. Okay, so whatever. Back on track here. What I was, so there's like act as an advisor, storyteller, a debater, screenwriter. Let's see, is there like a tutor? As an AI writing tutor, DIY expert. I will provide you with a student who needs help improving their writing, and your task is to use artificial intelligence tools such as natural language processing to give the student feedback on how they can improve their composition. That's not what I want. A teacher? Teacher. Mathematical history teacher, teacher of React, English teacher, philosophy teacher. Okay, let's see. Chat GPT teacher. Prompt. To tutor you. Interesting. Okay, let's actually spend some time, right? I have 15 minutes. Let's go through the flashcards, and then we'll read probably a few pages. There's some interesting stuff here, though. I'm kind of getting excited for it. So let's see. A fault is when a component of the system deviates from its spec. Look at that, bro. I didn't remember that yesterday, but I remembered it today. Response time is... I made this flashcard because it made a point of calling out the difference between response time and latency. Response time is the time, like when the request leaves the browser and when it settles, right? That's how long the user's waiting. Latency is how long the request is waiting to be serviced. Sending a request and receiving a response. Load parameters are the parameters used to define load, such as cache hit ratio, I think, response time, and what was the other one? There's another one here. Oh, read-write ratio. Okay, that was good. A few numbers, not parameters. Okay. Latency is the time that the request is waiting to be serviced. Handled. I'll take it. Dope. Oh, look at this, huh? Okay, so now we're doing chapter 2. This is what I originally envisioned myself doing, is that to give myself enough things to latch on to while reading the chapter, because I mean, this is pretty boring. I make the flashcards ahead of time. In this case, I get ChatGPT to do it. Maybe now I can also have it give me a brief summary of the overview of the, like an overview of the chapter. And then when I go into the chapter, there's a lot more things to hold on to. Anyway, so duplication in data models. I don't know what that is. Duplication in data models refers to I'm like really excited right now. The ChatGPT stuff is. I feel like we should. I feel like that's what this is. It's we lean into LLMs and learning about them and how it can be used to make this go smoother. Anyway, duplication in data models refers to. Oh, that's an interesting prompt. I was just thinking, why don't I ask ChatGPT how would I create the ultimate ChatGPT tutor? That could be interesting. Okay. Duplication in data models refers to when values are not normalized. They are not standardized, and they're using human relevant information as the data value rather than the ID. This leads to each record storing its own piece of information rather than referencing one. And then just for fun, the problems of duplication is like updating it is very hard, but it does provide the benefit of faster query times. You don't need joins. So we'll leave polyglot persistence. Oh, this is like combining solutions in order to get the benefits of all of them, I think. It's when they are combined. Okay. What are the advantages of the document model? Data locality, and flexible schema. Okay, so schemaless and flexible allows nested structures. That's another one. Good for data that naturally fits into documents. Okay, and useful when one document corresponds to one object. All right, we didn't know any of that. When is the document model a better choice than the relational model? The document model is a better choice when you need nested values. When data is frequently read as a whole and relationships are simple or embedded. Or when you need flexible schema and can tolerate some data duplication. Let's edit this to be not a sentence, but let's do this. Ability. So when okay. I like that. Wait, what? I don't know what just happened. What are the key characteristics of a relational model? Foreign keys, Structured data with schemas, tables, and foreign keys uses SQL for querying, enforced normalization and strong consistency. Decades of tooling or ecosystem support. Hard. Nodes and edges. It's, I don't know. They let you specify what you want without describing how to get it, which simplifies logic and allows the database engine to optimize execution. Okay. What are 3 primary data models discussed in chapter 2? Documents, relational, and graph. Oh, impedance mismatch. It's when your data model doesn't match the application data model and you need a translation layer in between. Graph databases. This one, I'm not a fan of this. I'm going to get rid of this. I don't care about that. Normalization is referring to an ID which identifies human relevant information rather than storing human relevant information in the table itself. Practice of reducing duplication in the system by having predefined human relevant information that is referred to by an ID. When is the document model a better choice than the relational model? When you need flexible schema, you can tolerate duplication, and you have simple relationships, and you want to read fast. Okay. A data model is how we structure our data, and it is important because it defines how we think and solve the problems that we are solving. Applications and databases, influencing design, maintainability, and performance. This I don't know. So there are downsides of imperative queries embedded in application code. So they're more error prone, hard to optimize, and tightly couples business logic and data access logic. Okay, so that was all of them. There was one about languages. Let's get rid of this. There's 5 minutes left. Okay, we could read a section. I think I remember reading about this. It's like kind of funny. So it's talking about it's providing some history. Let's see. With I think I remember this. So in the tree structure of the hierarchical model, every record has one parent in the network. A record could have multiple parents. For example, there could be one record for the greater Seattle area region, and every user who lived in that region could be linked to it. This allowed many-to-one and many-to-many relationships to be modeled. The links between records in the network model were not foreign keys, but more like pointers in a programming language. The only way of accessing a record was to follow a path from the root along the chains of links. This was called an access path. I think I remember, and if you delete it, you lose all the data or something. In the simplest case, an access path could be like the traversal of a linked list. Start at the head of the list and look at one record. It says, oh, you would forget where it is. But in the world of many-to-many relationships, several different paths can lead to the same record, and a programmer working in the network model had to keep track of these different access paths in their head. That's right, yeah. A query in CodeAzel was performed by moving a cursor through the database by iterating over lists. Yeah, I remember this. It's pretty funny, actually. If a record had multiple parents, the application code had to keep track of all the various relationships. Even CodeAzel committee members admitted that this was like navigating around an n-dimensional space. Although manual access path selection was able to make the most efficient use of the very limited hardware in the 1970s, the problem was that they made the code for querying and updated the database complicated and inflexible with both the hierarchical and network model. If you didn't have the path to the data you wanted, you were in a difficult situation. You could change the access path, but you had to go through a lot of handwritten database query code and rewrite it to handle the new access paths. It was difficult to make changes to an application's data model. That's a funny problem. All right, so I didn't really write stuff down. I'll kind of go over that again, maybe. Actually, here, no, I'm here right now. Let's see, 1, 2, 3, 4. This was all hierarchical data. Good enough. All right, done. Oh. I didn't know ChatGPT was still on top, my bad. So all the notes that I just took, let's see if I like I delete. Oh, and it's still on Croatia too. So like, if I get rid of that, yeah, that's a bummer. It was there the whole time. Whatever.